So this video is going to focus on a motorcycle jumping a ramp to then jump or cross a cliff. So we have our motorcycle here, and then we need to have a certain minimum speed, and then the ramp angle is 20 degrees to the horizontal, so the parabolic trajectory negotiates a 50-foot wide cliff. And then we have a motorcycle length that is 5 feet in length, so we have to adjust the actual jump distance at 55 feet. So that's a 50-foot cliff width, but then we have to jump 55 feet for the tail wheel of the motorcycle to land at the safe point of the other side of the cliff. So we can use this formula here in projectile motion, the range of a projectile. So we have the initial velocity or the launch velocity squared times the sine of the ramp angle 2 theta, or twice its angle, divided into gravitational acceleration. So we could take the 55 feet safe distance of range and make it equal to initial velocity squared times the sine of 2 times theta divided into 9.81 meters per second squared, which is the acceleration of gravity, gravitational acceleration on Earth. In the US system, it's 32.2 feet per second squared. So 9.81 times 3.28 feet to a meter. So if we were to solve for the VO squared, we could convert this equality into a one-line algebraic expression. So we could just multiply the 16.8 times the denominator of 9.81 and make this equal to the numerator on the top here. So then we get VO squared times sine of 2 times the 20 degrees. And make sure your calculator is in the degree mode, not the radian mode when you do this. So sine of 40 degrees. So if we take the left side, we make this equal to initial velocity squared, VL squared, times the sine of 40 degrees. So we get 0.6428 times initial velocity squared is equal to 164.808. So we can solve for VO squared by dividing 164.808 into 0.6428. So we then solve for 256.4, but then we can find the square root of both sides to get rid of VO squared. So that's just the square root of 256.4. So that's 16 meters per second is the minimum launch velocity of the motorcycle that's required. So we could multiply 16 meters per second times 3.28 feet to a meter. So we get 52.5 feet per second is 16 meters per second. So we know that there is 22 feet per second for every 15 miles per hour. So if we take 20 seconds as a ratio times 52.5, we get 35.8 miles per hour. And so that is rounded to 36 miles per hour is the minimum launch velocity of the motorcycle, and that's also equal to 58 kilometers per hour. So next we can focus on the maximum height. So how high will the motorcycle reach at the center of the parabolic trajectory, so that is the height from the end of the ramps horizontal, and then we go up vertically to the top of the parabola center point, and then symmetrically the other half to the other side of the cliff's platform. So we can use this formula here. It's H max is the initial velocity, v sub o squared initial velocity times the sine squared theta divided into 2 times gravitational acceleration. So we can get the meters per second equivalent to 36 miles per hour. So this time we flip the ratio to 22 feet per second for every 50 miles per hour. This converts the miles per hour to feet per second, and then we divide the feet per second into 3.28 to get the meters per second. So 16.1 meters per second. This quantity squared then times the sine squared theta 20 degrees. So the way to calculate this sine squared theta is to take the sine of 20 as you would, so 0.3420. Then we take the sine of 20, 0.3420, and we square this value. This becomes 0.117. So sine squared 20, or sine squared 20 degrees becomes 0.117, and then we square 16.1, we get 259.21 times 0.117 times 2 times gravitational acceleration, 2 times 9.81 meters per second squared, so 19.62. So this just becomes the ratio as such, and then we have a 1.55 meter maximum height. So multiply times 3.28, that's 5.1 foot height, or 1.55 meters. So that's how high the motorcycle will rise as it's jumping over the cliff. And so we can call 55 feet is the range required, including the motorcycle's length. And then we'll just call the 50 feet as the cliff width. So we'll put that there at the last part. So last one to calculate is the time of flight. How long will it take to cross the cliff? So we can take 2 times the initial velocity, or the launch velocity, times the sine theta divided into gravity. So 2 times 16.1 times sine of 20 degrees divided into 9.81. So this becomes 1.12 seconds. Then we rewrite the 50 feet as the cliff width, but we need 55 feet range, including the length of the motorcycle. So it's a minimum launch speed. So more or less, if the motorcycle has reached a speed of 40 miles per hour right when the tail wheel is leaving the ramp, the tail wheel will displace and then land at the other side of the platform, just exactly at the distance of the 5 feet going down here. So we could just say the specification for this particular application should be a 40 mile per hour launch speed, just for safety. So the motorcycle will actually, its tail wheel will be a little bit farther ahead here. And so again, it's not really the distance, it's not the weight, it is the launch speed that is relevant, because that is the horizontal vector, and then it makes a parabola because of the vertical gravitational vector directly downward. So when we put these two together, we get a quadratic function, a parabolic trajectory. So this is an upside down parabola. It would be negative x squared plus b something and then plus c constant. So this is a quadratic function, but you can use those 3 formulas. So if you're working on a homework problem, or you're working on a project, or maybe you're actually planning on jumping over a cliff with a motorcycle and you want to get the calculation right so you don't just have the front wheel land. So if you just set it at 50 feet, the front wheel would land here, and then you go plow and you crash down, and oops, and you probably don't get a second chance to do that. So you have to include this motorcycle length into the range. So it should be 55 feet calculation, or 16.8 meters. So you'll take off and go. So by the time the tail wheel is reached 36 miles per hour, it will then go and increase in altitude by 5.1 feet and then come back down to level plane, and then the tail will land right here. Poof. And then you go across and you can show off how cool you are. But if you go to 40 miles per hour, then it's probably something that we could do the calculation, but you could estimate it's going to be like 40 at the tail wheel, and then it's going to go up a little higher and then land something like that, like right here. So you probably want to set it at 40 miles per hour, but the minimum speed is 36 miles per hour. Maximum height 5.1 feet and flight time 1.12 seconds. So thanks for watching this video and have a great day.